Okay, this is problem number 3 from your homework. I just want to work through this so that you're clear about the steps in the process for linear programming. So what we have an objective function, that's Q. So we want to minimize 4a plus 5b, but we have to minimize it relative to the constraints. The constraints we are given are right here. So these are my constraints. I need to map the constraints so that I can figure out my feasible region. Once I map that, then I can find the vertices, and then I have to evaluate this function Q at each of the vertices. So what I choose to do is, first of all, I need to graph what is here. So A greater than 0, B greater than 0, that just means I'm in the first quadrant. Now, what you will see me do over and over for consistency is, see it's listed A first and B second. Every equation has A first and B second. That tells me that I want to label my axes as A and B. So for consistency, you could do it the other way around, but since my objective function and all my constraints are A and then followed by B, I will make A my x-axis and B my y-axis. Then it's just a matter of graphing the lines. So if I've got the constraint A plus B is greater than or equal to 8, I need to graph the line A plus B equals 8. So the best way to do that is just to pick values for A and B. If A is 0, then B is 8. If B is 0, then A is 8. And because of this greater than sign, I will be shading above this line. So if I label my axis, well, before I label my axis, let me back up. Let's go look at the next line. So you've got 2A plus B is greater than or equal to 10. So I need to graph 2A plus B equals 10. So I would need to pick points for A and B. If A is 0, B is 10. If B is 0, A is 5. So my A-axis needs to scale up to the number 8. My B-axis needs to go to 10. So I think I should be okay. So I should be good doing this 10 by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So with the blue line, that is 0, 8 right here, and 8, 0, which is right here. So I will draw the line that connects those two. Okay, that's good. And then with the red line, that's going to be at 0, 10 and 5, 0, which is right here. So if I connect those, okay, so now I've got the lines. I need to shade above both of the lines. So shading above the blue line and above the red line, that only means this area here. So that is my feasible region because I'm shading above the red line and above the blue line. If I had been shaded below, that would be the region that's bound here by the origin. So now once I know the region, I'd figure out what are my vertices. So that's a vertex right there. Here's one right here. And here's one right here. I have 3 vertices, okay? So the first one I know 0, 10, and I also know 8, 0. So those that I know, so my vertices, and if I write that down, I know it's 0, 10, and 8, 0, okay? So those two I know. I just need to figure out the intersection. Now graphically, when I look at this, it looks like 2, 6 is my graph, but that's meaning that I drew a very perfect graph, okay? But I gotta figure out maybe that's not the case. How would I figure it out if my graph didn't show it, or maybe there were fractions for the numbers? So I need to find the intersection of the 2 lines. So A plus B equal 8, and 2A plus B equal 10. The way you find that, you solve one equation for one of the variables. So I'm going to say that this means that A is equal to 8 minus B, and then I'm going to plug that in to the other equation. So what I'm going to do is to say, use this other equation, and you've got, what, 2a plus b equals 10, 2, and I'm going to substitute this value for a. 8 minus b plus b equals 10. So that means that 16 minus 2b plus b equals 10. That means minus b equals minus 6. So b is equal to 6. And if b is equal to 6, you go back to either one of these equations. So a plus 6 equal 8. That means that a is equal to 2. So 2, 6 is this point. So that's the point 2, 6. And so now my vertices are just simply this: 0, 10, 8, 0, and 2, 6. So I need to evaluate my objective function, which was 4a plus 5b. So evaluate this at each point. So at 0, 10, at 8, 0, and at 2, 6. So when I substitute the values of a and b, so for 0, I'm going to get 4 times 0 plus 5 times 10. That's, what, 50? And at 8, 0, that's going to be 4 times 8 plus 5 times 0. That's 32. And at 2, 6, I get 4 times 2 plus 5 times 6. That's 38. Okay. My goal was to minimize. If I look at the original problem, minimize that function. So that function is minimized wherever I see the smallest number. So I have a minimum. So a minimum of 32 at the point 8, 0. Okay, so that's it. So the main process, as you can see, several steps. But if we follow through this same process every time, you've got an objective function. Your goal is to take the constraints, so the constraints you have right here, graph the constraints. And then once you graph the constraints, that will show you what your feasible region is. Once you see that, you will know where your vertices are. Your vertices are the boundary points of the feasible region. So in this case, I had 3 boundary points. Once I get the boundary points, then I'm able to plug them in and figure out if it's a minimum or maximum, okay? Now, one other thing you could do, when we get to this equation right here, when I'm trying to solve this system, so I've got a plus b equals 8, 2a plus b equals 10. Another way of doing that is I could set up an equation that AB is equal to the inverse of the matrix of coefficients. So that's 1, 1, 2, 1 inverse times the solution matrix, 8, 10. That's what we did in the last section. So you'll have your calculator on this test. So you could certainly do that. I could say, let's solve that. So I will create a matrix 2 by 2, and that's going to be 1, 1, 2, 1 inverse times, and this is going to be a 2 by 1 matrix. So change the dimensions. So my 2 by 1 matrix is 8, 10. So 8, 10, and there I get 2, 6. So that's what I just found a moment ago. So if I come back over here, that is 2, 6. That tells me AB is equal to 2, 6. So that's another way to use your calculator in order to get the answer.